Okay, so now we're going to do one of these balancing redox reactions in a basic solution. So I'm going to be going back and forth from my original steps here, but we're going to do number 5 on this, the first of the basic. Okay, so again, what you should notice when you walk up to one of these reactions is you should see something that looks incomplete. And the way that I know that one way that I know that it looks incomplete is because I'm seeing these ions. So sometimes I like to use the language that there had to have been some sort of carrier ion to get this into solution, for example. So if I'm going to get nitrate into solution, it had to be on some cation, like a potassium or sodium or whatever that cation is. So I'm looking at something incomplete. It must have a little bit of the sense of being a net ionic reaction because I'm missing some of these other elements, and that's going to be fine. But I need to go ahead and balance these things. The other clue that you see sometimes is that I have hydrogens in this case on the right-hand side, and I don't have any hydrogens over here. There's got to be some other elements that are going to get added into this. All right, remember here were systematic steps. Assume the process takes place in an acidic solution. It says this is in a basic one, but that's fine. We're going to assume acidic. You'll see why at the end here. This can be altered. Write 2 incomplete half reactions, and then we're going to balance those. All right, so again, let's go ahead and make sure that we're doing a good job with this, and let's just write down the oxidation numbers for each of these things. An element by itself is always 0. Something that has a combination of oxygens, first we give those electronegative oxygens their electrons first. So I'm going to assign those as a -2. And there's 3 of them, so right now I'm at a -6, but I'm going to have a -1 left over. This must be a +5. Hopefully you're getting a little better at this. Hydrogen's kind of like the opposite of the oxygen in that we're going to assume that it is a +1. We're going to assume that it has given up its electrons to something else. And so I'm going to go ahead and assign it a +1 to begin with. And this needs to be neutral when everything is said and done. So the nitrogen must be a -3 there. All right, here's my oxygen. Give those -2s out first to the oxygen. Assume that it's got its octet being electronegative and all. And so I'm going to have -4 collectively among the 2 oxygens, and I need to have 1 left over. This is going to be a +3. All right, now let's search out what it is that's being oxidized and what's being reduced. Aluminum is going from neutral to a +3, and so it looks like this is my thing here that's getting oxidized. So I'm going to write the oxidation half reaction first. Remember, I like to remind you to hug, like make your arrow in the middle and then hug it on either end so that you have room to add things. So aluminum is going to go to, and then AlO2 minus. So we're just taking the species that has the oxidation happening. And whenever I'm doing oxidation, Leo the lion or oil rig, so Leo losing the electrons is oxidation. So I'm going to have some electrons over here somewhere. So maybe I'll just write that in. I may need a number that goes there. But this is my incomplete half reaction. Here's the reduction. By the way, I'm going to need a lot of room for these. In fact, I may have already left myself very little down here. You'll see why in a bit. Let's get the reductions. Pretty straightforward, then it must be the other one. But let's just check. Gaining electrons. This had 5 too few to be neutral, and now it's ending with extra. So I definitely think that this is the reduction here. So this nitrate, and it's going to go to ammonia. Okay. So I'm going to need, I have a need here for some extra electrons, but I'm gonna fill that number in a little bit here. Okay, if you were looking at the sheet that has our kind of systematic steps, I'm going to start balancing these half reactions. And so first you always start with the things that are not oxygen or hydrogen, so my aluminum. All right, one on this side, one on this side, so that's balanced. Then we go in this order. Now we're going to look at oxygens and we're going to add waters. So I have 2 oxygens over here. I need 2 waters. Over here, 2 H2O. Now I'm going to balance with hydrogens, and I now have 4 hydrogens over here, so I need plus 4 H pluses over here. Then we're going to balance charge. So I like to go to the side that doesn't have my electrons. This is what I'm using to adjust the charge. So I like to see, what am I at over here? I happen to be at neutral. Remember, the goal is not to be neutral. The goal is to have the same charge on both sides. So it just happens to be neutral over here. And so what I'm going to do is I'm going to come over and I'm going to take my 4 pluses, -1, -3 more electrons to get me to neutral on that side as well. All right, so that is at least a balanced half reaction now. So let's do the same down here. 1 nitrogen, 1 nitrogen. Okay, oxygen next. Looks like I'm going to need 3 waters over here to balance the oxygens for those 3. Now I have 1, 2, 3 hydrogens plus another 6. So I have a total of 9 H pluses that I'm going to put over there. Now I need to balance charge. It looks like this again is coincidentally going to be neutral over on this side here. So I need to make this side neutral. I have 9 pluses and then a minus, so I'm at 8 plus with those. I'm going to need an extra 80 electrons right there. All right, so here are my 2 balanced half reactions. Now I'm going to try to match these things together through the electrons so that the electrons will cancel. What we're saying, this is the crux of this type of thing. When you are looking at reactions normally, we don't tend to write out electrons unless we're doing something like these half reactions. So it's really hard to just look at a compound and know how many electrons are there. And in these redox reactions that are having electrons transfer from one species to another, all of this is just bookkeeping for my electrons. So that brings us back to knowing 3 electrons are hanging out over here. I needed 8 to make this happy. And so now I need to balance these 2 half reactions. Again, this is kind of a cross-multiply sort of concept. I'm going to do a ×3 on this one, so I'm dealing with 24 electrons on either end here, and this one is going to need a ×8. All right, so now I need to do that very careful process of distributing in and paying attention here. I'm just going to start up here, so 16 waters. Okay, there's a lag. I'm looking at my video right now. I notice there's a lag between my voice and the writing that I'm doing. Hopefully that's not distracting for everyone. Plus 8 aluminum, distributing in. 3 times 9 is going to be 27 H pluses, plus 24 electrons, plus 3 nitrates is going to 8 aluminum oxides, or that's something else. That's not actually aluminum oxide. Plus 24 electrons, plus 8 times 4, 32 H pluses. Oh, I'm trying to squeeze these in. Plus 3 NH3, plus 9 waters. Okay, now here's where the lengthy simplification process is going to come in. First of all, I do have stuff showing up on both sides. The easiest to identify is the electrons. Those always have to cancel, otherwise we did something incorrect. All right, but now look at what else I have. So I have 16 waters over here and I have 9 waters over here. Let's simplify that. I'm getting rid of all 9. I'm getting rid of 9 on both sides. It's just that over here, this is going to turn into 7 waters. I have 27 H pluses and I have 32 H pluses. So let's go to the smaller side, get rid of all of those. The 32 is going to be 5 H pluses. Okay. Then, so I've simplified this. And let's go back to here. So add the half reactions. So we've done this, but remember we were in a basic solution. So we're going to come back and we're going to loop around and we're going to fix this right now. So this is more of a thought process trick that we're doing. Anywhere that I have excess H pluses, like I have 5 H pluses right here, what I'm going to do is I'm going to add OH minuses to both sides of the equation. And in doing that, I'm going to allow every 1 OH minus over on this side to cancel, or to neutralize, let's call it, 1 H plus and make a water. But if I'm going to add ultimately 5 OH minuses over here to neutralize these 5 H pluses, then I still have to do the same thing to the other side of the reaction. I have to put 5 OH minuses over here. Okay. So again, bookkeeping. I still have 7 waters over here. So I'm going to add plus 5 OH minuses. This is now going to be 5 waters. Okay, so 5 H plus 5 OH minuses. Those are gone. I now have 5 waters over here. If I put 5 OH minuses on this side, I really need plus 5 OH minuses on this side. All right, if I have 5 waters over here and I have 7 waters over here, then I can change this to 2 waters. These are now all gone. And let's rewrite for clarity, because you can see this is a mess. All right, 5 OH minuses. So not 50, but I'm just going to, I don't know, that looks funny. But that's 5 OH minuses. Plus 8 aluminum, gone, plus 3 nitrate goes to 8. I actually don't know what to call that off the top of my head. I don't see that very often. I don't know if that's like illuminate or something. I think it is, but anyways. Plus 3 NH3. Did I get rid of all of those? I think so. I still have 2 waters. I forgot those. Let me put them over here. 2H2O. So you can see how important it is to be very careful when you're doing these. Again, it's all bookkeeping. As long as you're paying attention and really minding your arithmetic, things will work out for you. Now, if you want to do a check, we are claiming that this is now a balanced redox reaction that occurs in a basic solution. In fact, in this one, you can even see that it's utilizing some of the OH minus around from being a basic solution. Okay, we should still have a perfectly balanced equation. So let's do a couple spot checks. Here's 2, I'm going to look at oxygen. 2, 7, 3 times 3 is 9, so I have 16 oxygen over here. And then I have 8 times 2, 16. Okay, oxygen checks out. How about hydrogen? So I have 4 plus another 5, so 9. Okay, and I have 3 times 3. All right, so hydrogen checks out. 3 nitrogens, 8 aluminum, 8 aluminum. All right, so this is the final answer for that one. Again, these look like they're really complicated when you have all these scratchings and all this stuff, and you have big numbers, like you're probably not used to having a 27, for example, as a coefficient on these things. Don't get scared off by those if you see them. Be slow, be methodical, simplify more than I did if you think that'll help you. Like you can rewrite stuff to try to clean it up. All right. There we go. Hopefully that helped.